Hello, my name is William Johnson, and today I'll be talking to you about impulse. Now, contrary to what most people think, impulse is not represented by an I. It is in fact represented by the capital letter J. Furthermore, impulse is a vector quantity, not a scalar. Since it is a vector, it has a direction. We know that impulse is a vector because momentum, little p, is also a vector, and impulse is simply the change in momentum. There are three SI units to represent impulse. The first is Newton seconds, the second is kilograms times meters per second, and the third is kilograms times meters per second squared. Now, it is also important to know that impulse is experienced by an object during a collision. There are three different equations that we can use to calculate impulse. The first one is simply the change in momentum. Impulse equals mass times final velocity minus mass times initial velocity. The second equation is impulse equals average force times the change in time. With the third equation, we can calculate impulse by the area under the force versus time graph. In a real-life demonstration, I will show a hamster and a ball and how we can calculate impulse from this example. In the example that we just saw, the weight of the hamster and the ball combined had a mass of 0.52 kilograms. The initial velocity of the hamster and the ball was negative 1.0 meters per second because it was moving in the negative x direction. After the hamster experienced a collision and was pushed back with force, its final velocity was 3.0 meters per second. The change in time for this whole collision was 2.5 seconds. We can calculate the impulse of this demonstration by using the formula impulse equals mass times final velocity minus mass times initial velocity. The mass of 0.52 times the final velocity 3.0 minus the mass of 0.52 times negative 1.0. After you do your calculations, impulse turned out to be 2.08 kilograms times meters per second. We can also take this a step further and calculate the average force exerted on the hamster. Since we've calculated impulse in the step above, and we also know the change in time to be 2.5 seconds, we can calculate the average force, which would be 2.08 divided by 2.5, which would give us an average force of 0.832 newtons. As I mentioned before, another way that we can calculate impulse is the area under the force versus time graph. In this example, we see that in this graph, the area is of a triangle. So you have to know that the area of a triangle is equal to 1/2 base times height. Also be aware that the time is given in milliseconds, and this must be converted to seconds. So we see the time that starts at 1 second and ends at 2.5. So therefore, we know delta t is 1.5 milliseconds. But as we convert that to seconds, it'd be 0.0015 seconds. The force max is given to us as 18,000 newtons, and we can use this as our h in the area of a triangle equation. We are now ready to calculate impulse. The impulse is going to be 1/2 times 0.0015 times 18,000, which would give us an impulse of 13.5 newton seconds. As we did in the previous example, we can again calculate the average force by using the impulse divided by the change in time. This would be 13.5 divided by 0.0015, which equals 19,000 newtons. Now we can think of some conceptual examples with impulse. In this example, we have two men both standing 30 meters above the ground. The man on the left is going to jump off the building and land on cement, while the man on the right is going to jump off the building and land on a snowbank. So between these two men, which ones do you think will experience the most force and is most likely to get hurt? The answer for this is the men in cement. This is because the change in time for the man on the left is going to be much smaller. The man on the right in the snowbank is going to experience a lot less force because the change in time when he lands in snow is going to be much higher. This is also a relevant example with airbags in a car. When you're in a car collision, the airbags deploy, which allows the delta T in the impulse equation to be much larger. When this happens, the force experienced is also much smaller, and you're less likely to get hurt. Lastly, we must also note the impulse momentum theorem. This theorem states that the change in momentum of an object equals the impulse applied to it. Therefore, the impulse equals the change in momentum, which also equals mass times velocity final minus mass times velocity initial. Thank you for watching, and I hope you all learned a little something about impulse today.